because in general the debugger is pretty good, but there are some things that could be improved. For that, I created a very simple C-side application that just recursively renders a div until level, I think, 100 here. I think I have a breakpoint in there. Yes. So what you can see in the debugger is, first thing you see a bold text, and the bold text is, it marks all the occurrences of the current selected method. So here I am in render level on, and there's also a block render level on, and if I scroll down, you can see there's a lot of C-side stuff going on, and if you just want to find out how to get back into your main method, it's like going to your home context, you can just see it. And what it also does is, if you have an overridden method, it would display it in red, which is not the standard behavior. Now, this is a very simple example where I just have a recursion of 100. But what if you have a recursion that you didn't control? Like, you made a mistake, and it's running, and you just see your garbage collector cursor appear, and you're like, wow, debugger. And then you see the top of the stack, and I mean, you can scroll down, but if you have, let's say, 1 million frames, then you cannot scroll down. It will scroll to the bottom, reload the next frames, and you can repeat this until your computer just blows, because it's just too much, the image will crash. But what you can do is you can go to stack and jump before recursion. I will tell you, do you want to jump back 1,200 frames? And I say, sure. And now I'm at the beginning, where this function is called and the level is 100. I could increase level to 100,000, but I only have 10 minutes, and it takes like 30 seconds or a minute to figure out that there are 1.2 million frames, but it will figure it out and it will tell you, do you want to jump back? Yeah, you can. So I think that's everything. Excuse me, I think that's everything in this debugger. And the next thing that I want to show you is, what about objects that you can't really debug? Like, I want to know when the height of this launcher window changes, and only this window, and not the debugger window that will pop up. So I can just, open the debugger on the window. Here's the window manager. It has lots of windows. And the first one is our scheduled window for the launcher, and I can say, we'll open the Inquisitor on this thing. Well, Inquisition. Okay, so it will ask you, what do you want to observe in this object? And here you can say, well, let's use the height, for example. And then you have the list of all the objects that you're observing. And here's the 0, which means there is no change to this. And you see, when I resize this window, nothing happens, because it wasn't the window that we inspected. But if I change this value, this window, you can see there are like 60 invocations, and you can see all the values. And I used that to find out when a damaged rectangle of a window had a certain value, because this is impossible to debug otherwise. And you could just double click it and you see the stack, and you can see, oh, it's in this function, and you can just set a breakpoint there, and it will just help you to find the place where you want to go. And you can uncheck this, and I don't even know what the other checkbox was for anymore. Anyway. Another thing in this regard is, let's create the dictionaries and let's inspect them. So here I have dictionary 1 and I have dictionary 2. Now, what if you want to debug, this is a stupid example, but what if you want to debug add put in dictionary for a certain kind of dictionary? We also have to do musician, so that we so that we inspect this dictionary. And you see it here. And when I go to the implementation of dictionary output, you can just add a breakpoint or a one-shot breakpoint for just one object. I can select it, it will list me all the observed objects of this kind of class. And now when I go and change the value of the other dictionary, nothing will happen. But if I change the value of this, it will just hold at this breakpoint. Yeah, I think that's basically almost it. Just have one more thing. When you have temporary breakpoints, I mean, temporary breakpoints are totally awesome. You can just fire them, and if you, let's just go to commands, you can safely add a one-shot breakpoint. You add a one-shot breakpoint, and then you close the window, and maybe you have tons of one-shot breakpoints, and they fire, and in order to reactivate them or rearm them, you have to go back to the method and right-click and say rearm this probe. And that's a bit annoying, but you can say list me all the temporary probes, and here you see a checkbox, which means currently this is armed, and if you uncheck it, it's dearmed. And if it is automatically dearmed, you can easily just rearm it. I think that's it for that part. I have two projects that I want to show you, that's why I don't wait for questions. And the other one is, I have this application here. It's a stupid editor for text files in a project that I have. And what you can do is, just a simple example, you change this value to 0 and you change. And you have undo. So that's just a typical Mac application. So how did I do this? Here I have Xcode, and Xcode looks totally rubbish. Here I have the zip file, and you see the user interface. And I have a document with all the outlets for all the widgets and some actions, which are called when the widgets change the values. And the implementation of these methods is a bit boring, but it still works. So how did I do this? Well, actually, these methods were implemented in VisualWorks. And here you see draw rectangle. I don't want to show this now. There are classes like here, which is the document class that I had in Xcode. So you see the class is named document and everything. And here you have the methods like when the return value changed, is called. And here you see there is a method pragma, which is a representation for this method needs to be compiled or needs to be available through Objective-C. And because Objective-C uses types and not all the types in this method are objects, you also have to say what kind the return type is. In this case, this is void. And here it does some sanity checking, and then it passes the current value of this, of the return value field into another function which is called setReturnValue2. So if we go to setReturnValue2, we get the end string. It's also a method return type void, because down here we're using a undo manager, and the undo manager already comes with Objective-C or with Cocoa in OS 10. So you can just say, hey document, tell your undo manager that it can undo this action by executing setReturnValue2 with the current value. And then I give it an action name, so it looks good when I click on the edit menu. And then I set the value into my model, and that's it. So this method is executed when I change the value, and in the application I have 10 minutes over. Oh no, sorry, my head. Happened in my head. If I go to the corner down there, the screen will just turn black. I just forgot about it. Yeah, so I get a very native Mac application, and you know, if I check this value, and you see it's marked, edited, and I have all these benefits that I have in a Mac application, and it's written in VisualWorks. I have another example that I want to show you. It's called test app. And what it does is, it draws a gradient. So not really fancy, but it draws the gradient using Cocoa. So you could also add color animation or whatever you like to this. And it also has a text view, which is totally native, and you can change the font and all that crap. But what it can also do is evaluate this, or evaluate this. And you see tons of numbers or zeros. And yeah, I mean, if you increase the font size to 360, then you have huge zeros, which are rendered perfectly. Time's up. So that's what I want to show you. If you have questions, just ask, but not now, because the other one's waiting.